Hello and welcome back to another LeetCode problem. Today we're going to be doing the problem of the day for June 13th. It's going to be equal row and column pairs. Pretty straightforward problem. So you're given a matrix n by n. So let's just draw that with some values. Yeah, okay. A little tired today. 176. And you're asked to get how many combinations of same row and columns are there. So if you have a row and a column that have the same values, that's going to be one combination. And so for this example, this is one row and this is one column. And so that's going to be the combination that you're going to have. So you're going to have row 2, column equals 1. And let's actually look at this second example as well. So we're going to have a 4x4 this time. My amazing line drawing that I can't do at all. Okay, so we're gonna have 3, 1, 2, 2, 1, 4, 4, 5, 2, 4, 2, 2, 2, 4, 2, 2. Okay, and so if we actually take a look at unique combinations, so they said there's 3, so there, yeah, so row 0 and column 0 are one combination. And then row 2 and column 2 and row 3 and column 2. But what you can actually do is we can just take a look for each row, right? For each row, if we could somehow have the count of the rows, like if instead of having these rows, we could have them, we could store unique rows separately, right? So if we could just store like how many of these rows we have and how many of these rows we have and so on. So what we could actually do is, like, let's say if we have this row and we have a count. So the count here is 1. How many columns do we have that are going to equal this row? So if we do have some counts, like let's say what we're going to do is we have some counts, and for the counts, they're going to be unique rows, right? So there's going to be, let me actually make this bigger. So let's say like one row is going to be 3, and we're actually going to store these rows as tuples because tuples are immutable, so you could store those as keys of a dictionary. So we're going to have something like row this, and then we're going to have 1, 4, 4, 5. Then we're going to have 2, 4, 2, 2. And then we have 2, 4, 2, 2 again. So here the count's going to be 1. Here the count's going to be 1. And here the count's going to be 2. So that's how we're going to be storing these rows. We're just going to simply turn every row into a tuple. And then we are going to store them in a dictionary of counts. And then what we can do, it's pretty straightforward now. We're just going to iterate column by column. So let's say we're at this column. We're going to ask ourselves, how many rows do we have? And then however many rows we have is however many like pairs we can make with that column, right? So if we have this column 3, 1, 2, 2 over here, where's my cursor? Okay, here it is. So if we have this column right over here, 3, 1, 2, 2, this one, we're going to look at, okay, do we have any rows with that count? And if the count is 1, that means we can have 1. So let's just call this our res as usual or something. So let's have our res. So we're going to add 1 here. Now we're going to go to the next column. So we're going to be at this column. Do we have a 1, 4, 4, 4? No, we do not. Okay, we go to the next column. We do have that one. And how many do we have? Well, we have 2 of those. So if we have 2 of those, then we can make 2 combinations there, right? Because if we have 2 rows with this, so let's call those R0 and R1, and this is column 0, how many combinations can we make? Well, we make row 0, column 0, and row 1, column 0. So that's going to be our algorithm. It's pretty straightforward. Like I said, we're going to store all the unique rows with their counts, and then for every column we're going to go down, we're just going to ask ourselves, how many rows do we have? So we could technically store the rows and the columns, and we could do some like, we could compare the keys of both, but we could just do it in place for the columns, where we just, for every column, we ask ourselves, how many rows do we have? And then we can make that many combinations, right? So every single row in the rows that we do have with that column is one combination. And so we would make 2 combinations here, right? Because we have, where's my cursor again? Hard to find. Okay, well, there it is. Okay, so what we would do here is, yeah, for this column, we have 2 of these. And so we would add 2 here. And then we would add 3, and then that's the result. And that's what it is as well. So hopefully that makes sense. You store the rows with the counts, and then for each column, you just go one by one and you check, do I have these rows? And if I do, how many do I have? Okay, and so let's actually code that up. It's pretty straightforward, and it's kind of like an easy or medium problem. So we are going to have rows equals default dict. This is going to be an integer. We are also going to want to actually store like the dimension of the grid. So let's just call that n maybe. Okay. And so we're going to go down the grid row by row, and we're going to turn every row into a tuple, and we're going to add it into this. This is misspelled, and we're going to add it into this dictionary along with its count. So for I in range n rows, and then this is going to be. Oh, this can actually even be rows grid row. And so we actually do need to turn this into a tuple. Hopefully it lets me do this in here and not have to make another variable. It might not let me. Let's find out. Plus equals 1. Let's see if it does. Oh, I think it does. Let's see. Okay, nice. So we're going to go row by row. We're going to turn that row into a tuple to make it immutable, and then we're going to add the count of that row into the dictionary, and that way we're going to do the same thing for the columns. So for the columns, we are going to go column by column. So this is going to be for column in range n. What did I screw up? Okay, so for this column, it's going to be a little trickier. So it's actually, instead of calling this column, let's call it J instead. Because what we're going to need to do here is we're actually, so for the rows, we can easily get a row, but for the column, it's going to be a little bit trickier. We have to build it because the column is the second dimension of a two-dimensional array, so we can't, like, it's going to be a little trickier. So let's do that here. So column equals, we're going to make it a tuple, and then it's going to be, we're going to make an array here. So it's going to be grid I j. And so in Python, you can make this list comprehension for I in range n. So for a column, like for example, for column 0, this j is always going to be 0. But then we need to get every single value in the grid. Like let's say we're over here, we need to get every single value in the grid for every row. So if we're on, oh, we can draw that here actually. So let's delete some of this. Yeah, so let's say we're at, we don't need to make it that big. Let's say we're at this column over here. So this j is going to be 0, but then we need to iterate through all of these rows, right? So it's going to, so that's actually going to be a 0, 1, 2, 3. And so we need to get grid at the row, which is this 0, 1, 2, 3. So 0, 1, 2, 3. And then we need to iterate through all those. And then the column is always going to be the current column we're on. So that's going to be that j column there. Okay, and now that we have the column, we also need a result. So we need to check what's the count of this column in the rows, and then that's however many pairs we can add for that column. So if the count of the rows is like 2, we can add 2 pairs, because for every row that's in there, a pair is always going to be that row plus this column right here. And so that's going to be res plus equals rows column. And then if it's not in there, it'll just give you a 0 because it's a default dictionary. And we can just return res, and I believe that's it. Let's see if we screw anything up. Find out. Okay, nice. So let's think of the time and space complexity for this problem. But yeah, I don't think it's super hard once you realize that you can actually just turn an array into an immutable object, and then you can use that immutable object as a key in a dictionary. Then it's pretty straightforward on where to go from there. Okay, so time. So what are we doing? For this row, we are going to be iterating through the entire matrix. So that's n by n. And then for this column, we're going to be iterating through the entire matrix. And then we are also getting the count of that column, but that's O of 1. So basically I think this loop is actually technically only n, but then to build up this column, we have to make it n squared. I think this might actually be, yeah, I think this is, no, sorry, this would be n squared, because to make an array a tuple, you have to take every element and convert it, I'm pretty sure. So that would be n by n, because we'd go down n rows, and then for each row, it would be another n. Okay, so that's n squared. And space. So we are storing every single row in tuple format. which is going to be unsquared again, right? Like we're storing basically this entire matrix in tuple format. That's going to be unsquared. We don't need to store the columns because we can do that in place. Okay, so that's all for this problem. Hopefully you enjoyed it. It was a pretty easy problem, but still gave you some good practice with dictionaries. And if you did enjoy it, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.